protects 1%.
Sorry, I forgot to record.
Okay. And so because of that, so I saw that maybe you cannot have a vaccine that protects only 1%. And so most of this vaccine at least protects at least more than half of the population.
Yes.
Yeah. So I also changed. So I changed that interval. So that's why the parameters are, some of the parameters are changing.
Okay.
Yeah. But so the advantage for numeric, once you have the code the way I told Nando, and once you read these files, so there's nothing you have to change because you will just read the file and then it will read the new files.
Ah, okay.
It's only a problem if somebody reads the manual, if you have to write the manually from the table we have in the article.
Like from that table we have in the article. Right?
Yeah, so if you read them from the table, then that's because you have to every time change, you change the parameters. But in this case, you only just change the file you read and everything remains the same.
Ah, okay.
Yeah.
All right.
So Nandwa. Does Vincent have a problem with
his mic? I'm not sure. Yeah, he's just sharing. So how were you communicating like yesterday with Nandwa using Google Meet?
No, we didn't meet. I wanted to meet him, but we didn't meet.
Oh, okay, fine. All right. Yeah. Oh, yes. Welcome, Vincent.
Oh, I think my microphones are the ones that have problems.
Ah, okay.
But now we can.
Now you are very loud and clear.
Yeah. So Dr. I was asking, should I delete now the previous?
No, I also didn't delete them because just save them and then you read the appropriate files. No, when you are doing like this research, you never delete. You may find something important in that one later. You just save all of them and then you read only the appropriate files.
Okay. So
for example, instead of LB1 Mat1, it means you read LB1 Mat1 version 2. So V2 means, so I just put V2 means version 2.
Oh yeah, but they are different, yes.
Yeah. So they are different. So that you don't. So sometimes when you do this, you never delete before you are sure.
Yeah.
You might delete something you will want maybe later on because we'll still have some reviews about this, and you never know what the reviewer will say. Yeah. So have you saved them in that file?
Yes, I've saved them in the Matlab file.
So can you go up, select the up? So I don't know if John has access to these files.
Yes, I shared yesterday.
Yeah, sure.
Yes. So these were the files made by Elias. Yeah. And so since Nando maybe I saw that Nando was comfortable with this, so I didn't want to change it. So I was just discussing with him alongside these files.
All right.
Yeah. And so we are now. Can you go down a bit? So beta. So this is what we discussed with him. So Elias was writing parameters manually, right? From you see line 19 to line what? To line 24. And yeah, so this is what we discussed. So here it's okay. Elias was reading files, but he was reading these files manually. But so if we want to change this, so we have to read this from the files you have, so that we whenever the only thing change it is only reading the file. And I think this is what we discuss. You can go to line 13.
Yeah.
You see line 13 to line 15. In that case, you are loading the mat file, which contains the mat file of the first wave. And then after loading that mat file, then you have what? You can now get files, you can read those parameters from that mat file. And so whenever you have line 13 to line 15, the only thing you will be changing is just only line 13. You read the appropriate mat file, and then the rest will be kept fixed. Is that okay?
Yes.
Yeah, because the first thing we have to make sure is that we supply the correct parameters. So just to start with, because we want to illustrate this so that to start, you can read now the appropriate mat file at line 13.
Yeah, so I replace by, so I will replace by mat version
Wave
2.
1 version 2. Yeah.
Uh,
You can just assume that you want to rename that one, then you copy it.
Yeah.
No, don't even, or maybe double click on the other file in the same way you want to read.
Okay, so version 2.
Just double click and then so copy whatever is on the command window, because so it's load. Copy everything, just the whole load file, because that's what you want. So assuming if you go to wave 2, then you will just only change that one, and then you, in fact, so the only thing that it will happen is what? You just replace W1 by W2, because I think the only thing that's changing is just one. So we have 1, 2, 3. And
Yeah.
once you have that mat file, you can first check how parameters are appearing. You have so many things in the workspace. You can first create the workspace and then you reload that file. Clear the workspace. CLC is just cleaning the command window. Just put clear. Don't close. Just put the word clear in the command window. That will clear the workspace. Because so yeah, and then now reload the line 14. You can copy or double click on there. So yeah, so so you want to be sure that you read the correct file. So you want to see the files contained in that. Yeah. And so now you can open PP and then you'll see. Double click just. And so because there's something I discussed with you, and maybe also because so according to this, vaccination only started what? Started after time point 320, right? So when you check the files, you can check. So you can put this restriction in your model. Once, assuming you use the actual time points, then you will have that now the vaccination, the vaccine will be, the vaccination will be different because it will change. So before that one, you have vaccine, there's no vaccine parameters, but after some point, then you have vaccine parameters. But so that one will come to that one later. So you can read this file, so you know that you have beta, you have K, you have epsilon, you have phi, but epsilon. So there is a problem with this epsilon, but that one will work on it because it was taking 1, but we don't have 1. No, but also, so in the first wave that is 1 because in the first wave epsilon is 0, right? And theta is 0.
Vaccination function is not there by the way.
Yeah, in the first wave we didn't have vaccination, so in the first wave, vaccination is 0, right?
Yes.
Yeah, and so you can just go back to the other end and then you start reading the file. These parameters, just close PP, and then and comment line 15 and 16. Yes, and then so it is what? So beta is equal to bet, whatever, gamma is equal to PP, gamma, K is equal to PP dot K. I think those ones are okay. V is a pi, right? Theta is equal to 0. So in this case, theta is equal to 0 because we are in the first wave, right?
Yeah.
If you go to the second wave, you will have the theta for the second wave. Even in the first wave, epsilon is 0. You can also still put epsilon 0 in the first wave. API, so psi is 0 in the first wave. Line 16, so line 16 psi is, that one is 0.
This one, huh?
Yeah, epsilon is 0, so because those are the two parameters associated with the vaccination. So they are 0 in the first wave. And then phi is still phi, Q is still Q, right?
Yes.
And so those are the only parameters. Then you can now comment on 20 to 23. No, 20 to 25, all those parameters, because now you are reading the parameters from that file.
Yeah.
Okay, so having done this, what else do we need? And so the only thing you read the correct file in line 14, and then 15 and 16. You make sure that, so when you go to wave 2, you load, you see the parameters, you see the epsilon, then you read the correct epsilon. And so mostly the only thing that may be changing if you go to the other waves is, the only thing that you might change is line 16, theta and epsilon only, because those are the only things that will be changing when you go to the other waves on how you read them. Others, they will be the same files if you go to the first, second wave, and so on. And then you can go down. No, until initial conditions. So you see also, Elias has here 3 sets of initial conditions, right? No, 4 sets, meaning
4 sets.
For each wave. And so I think since I did the new simulations, this must have changed. So I can I send via chat?
Chat, okay, maybe yes, you can do it.
No, let me just reload my file and then send the new initial conditions.
Okay.
Because they changed because of changing parameters, so they might have changed. No, but we can continue, and then so once it loads, and then I will. So because you need the initial condition for each wave. But so this is the loop was for the second part, or maybe it was for the second part. But I see you have here the loops.
For the initial.
No, not for the initial condition. What's the difference between general and the COVID-19 model? What's the difference?
The difference was the one that were varying the parameters. Yeah.
Which one were you varying the parameters?
For the for the COVID-19 model.
And I was, because I've seen some loops in there. Oh, so this is still changing, saving the figures before I can get the initial conditions. So you can just do a test run, but no, let's deal with one. I think one at a go. So because once you make an appropriate file on the other end, then it's much easier to deal with this other one, because they're the same thing. The difference is just only the loop. So here, depending on the wave you deal with, then you read the appropriate initial conditions. Right? Yes. So you can now comment on what? Is it IC2, IC3, and then you leave IC1, because so we assume that you are dealing with the first wave. Yes. In fact, it's the first wave because you already the first wave, so you can comment on that one. And then I told you that if you just do what? But so in the first wave, time points were 0 to 50. So maybe I can do that one, 0 to 50. The start time was, I think, 1, right? 1, and then the end time was 250. That's like the 41 and the 44, because that one is to do. I think if you have access to Dropbox, these things is easier. So in the first wave, it is you start from 1, and start time is 1. Yes. I think it's supposed to be 1 or 0, but whichever. But 1 and then to 50, whichever you start with is okay, because this is still also the theoretical simulation. But if you do this theoretically, you can just use whichever time point you want to use. So the advantage of using the actual time points is, you know that vaccination started at time 320. I think it was 320. You can note that somewhere in a comment. And so you know that, so when you can put that into consideration, that when you reach at 320, then you have vaccination effect.
Start of vaccination.
Yeah. It was at time 320. You can still, because you have the Excel file, so you can just read the Excel file and then check where the vaccine started, the time point where the vaccine started. So I see B1, wave 1, and then no, so wave 1 will be the same, because initial condition for the wave 1 will not change. And then wave 2. So I'm sending, I forgot how to chart here. How can I? Oh. So I'm sending them in the same order of how they are appearing. So that is for the second wave. And then let me send for the third wave. Just click enter, that thing will go, just click enter. And then you remove the percentage sign in front. Oh, but yeah. Did you change the first one? I told you that the first one was the same. The first one, nothing was changing.
That the one that you have sent was for which one?
Second, third, and fourth. The first one, it doesn't change anything.
Okay. So
Just move back that bracket. No, move it back so that it closes the other end. Yeah.
okay, fine. I have replaced.
Yeah. Okay. Yeah. So, and then you go to start time, and then you can. There is a highlight on line 36. I don't know why. and as might not be used to go, just no problem, just go down there. And then because so you see the model you have IC4, because so you have to read IC1. You see the model equation line 52, the initial condition.
Mm. I
ICW4, that's the initial condition. So you have to put appropriate initial condition. It's IC1. IC1 B1. So because we are in the first wave, yeah. And then so that's okay. You can go down, right? And then try to run this. So a static workspace, what does it mean?
Attempt to add my path.
Can you go to line 14, just line 14? What does it mean, static workspace? Can you just kill and then see what happens? But there's an error, there's something highlighted on load. Can you put your cursor at line 14 because there's a highlight? You can specify the variables to load, whichever. Can you run again? But why is it complaining today? To add my param to a static workspace. Now, if you double click on that, because it was working, if you double click on the other end directly on the same way, the same one, LB1 mat1.
Yeah.
Double click on it from the current folder.
Okay.
But why is it loading on this other end? Can you go up to see what do you have before this?
For this.
No, just in your general model. Why is it not loading? If you can you,
or should I comment put your semicolons?
I don't think that is an okay. Just put, but I don't think that's a problem. Just double click on my param. What is this complaining about my param? Continue. Just scroll. I want to see what is contained in this my param.
Because just showing one
to the left. I want you to go to the. I want to until the end, but it's until line 9. Epsilon kappa. I think there is a problem with this. This thing here. You see, the files are renamed in the wrong way.
Okay.
Log beta recovery, because what is written in theta is supposed to be k, and then what is written kappa is supposed to be theta. So there is something I want you to. Let me see if I can do something from here, and then I send to.
Okay.
I want to send a line, and then I ask you to load this line. so that instead of running and then sending you the new file, my param road kappa and then detection, which one was I reading? But why is it that if you read it the other end, then it, can you just copy this somewhere?
All the
Just copy all of that. No, this file I've sent. I've sent you some. I've sent something in the message.
okay.
Just
one?
copy it in somewhere in your. Okay, yeah. Just copy that line. Put that line in the command window, and then. Yeah, that is. That's okay. Let me send you another one.
Okay.
I just want to receive that file from your side.
Okay.
And then have you seen the file I've sent?
My part.
Yeah, yeah.
This
That one
one.
I've sent in the message. My param is equal to my param.x1.
So I still copy in the works command window.
Yeah, in the command window, because I don't want us to put it in the workspace.
Okay.
And we just only need it to save. And then the last one I've sent you. I want to receive a new one, a new file.
Okay. So I
Just copy and then also put in the command window. It will save new one with the correct. You see the files have changed, the names have changed, even in your.
yeah. Mm.
Have you finished?
Yes, I've copied.
And then you enter, right?
Okay.
So I think it must have saved the correct files. Yeah. Can you go back and then close and then reload? Or just clear and then reload?
Clear everything.
Yeah, clear. Now reload that version 1 and then see if we are loading the correct one.
The version 1 for LB.
The same file you have been loading and the same one you have saved. I think now it's so. But why do you have detection 0? I think still there is a. I think still there is a problem, right? It means you didn't save. Yeah, so you saved -1. You see, you saved your file, and then you did put 1.
So for
so in short, you see, just look at your command window. What you saved? Save lb1 mat w. You did put 1.
so LB.
You see mine are labeled W1.
I think on W.
So he saved a new one instead of the previous. Yeah.
So that one should be W1.
So you can just change the name. You can just.
Oh, okay.
You can just delete one that you have in your current folder, and then you rename your W to be W. Do you have your W? Yeah.
So I put 1.
No, instead of starting afresh, just delete that one.
This one?
Yeah.
But it's already 1.
No, I'm saying delete it.
Remove the 1.
No, don't even remove one. Just delete it, and because you have.
Okay.
Because he already have another one. Yeah, you delete it.
Okay.
And then now there's one with W. So you rename that W to be 1.
The
Yeah, it is in fact the one you are LB1 mat WV2.
After W4, mat.
this one, yeah.
Yeah, so
Yeah.
it's W1. So that's for the wave 1.
I rename as 1, eh?
No,
Yeah.
only W is W1.
W1.
Yeah,
One.
there's W. Yeah.
Okay.
And then now load it.
That was it.
But there should be no problem in loading this file. I think there's still something wrong with your Matlab, and I don't know why. Because if you load from here, it loads, and if you load from your file, it doesn't load. Can you run your file again? Adding my can you Google that error and then you see what that error means? Just copy that error. Attempt to load my param to a static workspace.
Copy everything here.
Only the error. Only the error, not.
But so I start from here.
Only the error part, not the line where the error is appearing. Do you have something in declare variables workspace for nested anonymous functions are static? It means all variables used within the function must be present in the text of the code. I can't see something to figure out here. Just there is something maybe you can do, and I don't know why it is complaining, but there's something you can do. Can you just put the same thing, my param, before load, and then you put empty matrix
Before
in your file,
I put
just at line 13.
yes.
Whatever is complaining is saying my param, right?
Mm.
Yeah, can you put, and then you try to put empty matrix.
My
Write it, my param is equal to, and then empty brackets is equal to empty brackets, the square brackets. Try to run and then see if this one is attempted to work to add P, but I think there's a problem with this, your Matlab. Which version is this? 2022A?
22.
No, but it was working yesterday, and I don't know why today is complaining about this attempted to add this. So do the same. I don't know how you can add this to a static workspace, but it never complained this about yesterday. Why is it complaining now? Because it's now also complaining about PP, attempted to add PP to a static workspace.
Maybe John can try his version to see whether maybe there'll be a variation in just the few things we have done in this.
Because I also have the same thing and I can load it from, if you click it, you load, but when you run it, it doesn't load.
Okay.
And this is I've never had this problem with the load. Maybe can you load specific whatever the specific things you load. maybe what you do, so let me try something.
Mm.
Where you put load,
Mm.
and then you after load, comma, just within the same load.
Mm.
Within the
Comma.
same line, no, after mat dot mat and then comma. No, not within the, no, hyphen is just remains. When you write a string, MATLAB has to have, yeah, so comma. And that, in fact, it's suggested to you already. It's okay. Just move the cursor, it will take that. Oh. Maybe enter, I don't know if you enter, no, okay, then comma. In fact, it's suggesting to you, you have
PP something.
just you see the suggestion down and then you click on that suggestion down here.
So I
The
picked
param
PP.
you finished, you go to PP
PP
and then X1.
one.
Comma X1. Eh?
Yeah, all the variables in that one, yeah.
Yeah, that one.
Can you now remove the param in line 14? Now run and then see. Now check that error. So I think that's now your error.
Yeah.
Recognize function K. I think there is somewhere you used capital K and some another place you are using small k.
Yeah, sure.
Small K.
I'm sure there's somewhere you are using capital K and another one you are using. Can you check in your lambda?
Lambda, it was like, I think.
You put capital, whichever you use, just use any, provided it is consistent. Whatever you read the parameter line 14 or 15, and this K must be consistent.
So there's both small and capital in this model. So maybe.
So change capital to be small.
Okay.
Yeah.
No, but I think there's a problem. And did you change this model? Because at E seems to be kappa, and at lambda seems to be K. So that lambda at K is okay. That has to be capital K. And then the small k at E that you see in dy2, that's supposed to be kappa. And so you have to differentiate. And that's why I was telling you the other day that sometimes, to be sure, sometimes I always put two names, at least two variables. So you can just keep that capital K. We'll go and change it to the parameter. And then at E, because you are moving, the kappa is moving away. And you have the kappa
model.
coming.
In the model.
And then also,
I think,
no.
In the model, are they using just, there's nowhere there's capital K.
There's capital K can you check your lambda? Where is your lambda?
So lambda S then.
No, just check your lambda equation. No, there's somewhere. No, just go back to the same file first. Go back to the project file.
the PDF one.
The PDF.
Okay. This lambda.
Where is your lambda? Where is it defined?
So
in equation 2.
No, where is it defined? There's an equation for lambda.
Oh, lambda
an
is
expression. Here. Yeah, you see K is there.
Yeah, you are. So capital K. Yeah.
Whichever you use simulation, whether small case, it has to be consistent. So, and make sure you don't confuse. This is K. Can you go down to the equation? And then at E is kappa at E. Right?
Yes.
Yes, kappa, yeah, sure.
And there was some missing mu here at E. I think so, right?
I see.
No. In equation for E, there is missing mu because everybody has natural death.
Yes.
Yeah. So there is missing mu.
In the MATLAB file.
No, not in the MATLAB. In the equation, you see equation number 2.
2b.
Yeah, 2b. It's supposed to be kappa plus theta plus mu.
Oh, kappa plus theta. Okay.
Everybody has that natural.
Yes.
Let me also just verify that I didn't put the wrong equations.
Yeah, it's everywhere.
No, in my MATLAB it's okay. I have it.
But
I have it new.
It's not shown on the model structure.
That's what I'm saying. That one has to be changed in the model. Somebody has to put, and I think there's somewhere we said it. So in the simulation it's okay, but it's supposed to be.
What about here? It's given.
Huh?
It's given. It's here.
No, I'm saying in the E, you see E, there's E, mu E going out. Yeah, so it is there. It's supposed to be there. I know it is supposed to be there because everybody has natural death.
Yeah. So
Now,
it
can
was,
you go back to but MATLAB, your MATLAB has it. So it's just only changing equation number 2. I think that's just a typo.
yeah.
You
So-
see equation has mu, equation for E. Equation for E is equation number
2, I think.
yeah, number 2. So that's supposed to be capital K.
Yeah.
And
Capital K.
Capital K. And just to be sure that you differentiate, that's capital K.
Yes.
And to be sure that you differentiate, can you put this other one as cap?
Yes, sir.
Yeah, because so that you don't make a mistake of defining capital and small, and then you make and then also define it's also at line number 4. No,
So-
at dy4. That's supposed to be cap.
Yeah.
Yeah. And
Then we go back.
Now go back to your parameters. So beta, gamma. Oh, but no, that's just put that as capital K. That one you are checking before, that's supposed to be capital K. But you didn't have here kappa. So put the kappa now, cap. Is equal to pp dot cap.
Equals to.
So sometimes I will just put these two names when when you put parameters with more than one variable. That is not easy to but if you put one value, you may use 2 different cases and then you think it's the same. Now can you run? Let's see.
Yeah.
So you see now you get the simulations.
Yeah.
So Elias made 2 different files. So the first file is for the general model, where you can run this for different waves, right? Yeah. So you can do this for different waves,
Like
as you go on. Yeah. And so something you might not, because so when I go to this, when you go to the subsequent waves, then we initialize the parameters, right? Mostly those cumulative parameters like the vaccinated and then the recovered, because those are cumulative. They accumulate. If you recover today from COVID-19, even if you get another tomorrow, but you'll still be counted towards the cumulative people who have recovered or maybe who have been infected. So the infected, the recovered, those are all cumulative parameters. They're not daily parameters. But if you just go wave by wave, then you don't have to worry about adding the previous value, right? Yeah, but if you just doing these simulations, because this is wave by wave, so then you don't care about adding previous value. But if you want to combine all of this into a single file, then you have to keep note of the ending value in your simulation, and then you add that one to the initial value of the next simulation. But here, this will be wave by wave, so mostly you don't worry about that one. I did that one when I combined when you see the combined figure for the fitting. That's what I did. So I have to take into account the previous infection recovered, and then you add to the next one. And so since you are doing this, and I always, so you want these figures to be uniform, let me send you some file just to put in your figure, right? No, just set GCF color. Let me copy the 2 files, and then you never save your figures automatically. So I'm sending something in the chat. Just copy those one and then put below your figure after the plot of the figure.
This, sir?
Just copy everything, yeah.
And then
after plotting the figure, so because those are just, you will see the difference how the figure appears even after labeling, even after legend, even after title. So that's
Okay.
that's a different figure. You can just that's a different figure. You can go back. Maybe just immediately after line 72. So you see, so GCF, it means you are just giving your figure background color, no background white color. And then GCA, you are setting the font size of where the font size you want, the font weight you want, if it is bold, the font name you want, Arial. So this ensures that your figures are uniform. When you do your figures are uniform. Yeah, so it's uniformity. Sometimes I also even add the title. You can even take the title, and then you just copy everything from font size, font weight, and font name, and even all the others. But as I said earlier, you remove the titles.
Oh,
The title,
yes.
title is restrictive. Yeah, because that one is restricting us. Now just run this and then you see. No, but no, it's not an error. So don't worry, because when you put it, it's never a problem. I'm just saying that the problem is once you restrict yourself in the title, in case you want to change something, then you'll have to go and compute a new figure, because so that you change. But if you put everything in the caption, you only change the caption and you keep the same figure. Now run and then you see how your figure will appear. You see now the figure has white background.
Yeah.
And now everything is bold, the labeling, the population, and then the other end. So if you see that your lines are thinner, then you can increase the width of your lines. Right?
Yes.
Yeah, I'm just telling you the things you can do. Maybe you can put.
Maybe we can try. So with but this
no, don't change the font. The font is clear because font is just labeling. They are visible. They are somebody can use them. But if you want, you can put 12 if you feel they are narrower. I'm saying the plot lines. You can go to where you are plotting. Yeah, and then you go to the end of that one. You see line width. You can even put 1.5. And then you can remove grid if you just remove. I think there's only for the grid. Yeah, and then you.
leave that there thicker.
So that one you put as appropriate so that somebody can be able to. Somebody can see these lines, right? So that general model, I know. Can you go to? Do you have? Can you open the PDF?
PDF for the.
Yeah, can you go to where the simulation is starting? The numerical simulation is starting. Equilibria and then whatever. Numerical simulations and discussion. Can you go to the first figure? Maybe if you have a first figure. You see these figures. Are you seeing them? So you can replace these with appropriate figures. You see, there are 4 different waves, right?
Yes.
You have already gotten you have already gotten the first figure.
Yeah, that's 4.
So so because I said don't put the title for lambda 1 because we only have 1 lambda. So I think he was putting the title is okay because initially we had 2 lambdas, but we decided to go with 1. We can investigate another one later. So you can now replace this with appropriate figures in each of these waves. Yeah, right?
Yes.
And also legend, what is happening? You see the legend, you want the legend to appear right at the correct point. Can you check your figure? Because you don't want your legend, which is maybe where is your figure? You see your legend is thing obscuring one of the lines, right? You can change the legend position. Yes. Change the legend position, and then you can put best.
Oh, okay.
So
legend.
So positioning where
And
I
you know,
think
these things are what I discussed with you before, right?
Yes. I was trying to
No,
check.
I said when you do, you Google, but so can you put after the recovered R,
Mm.
after the no, after the
No, no, no.
recovered, because in the same region.
Legend.
Mm.
That's on legend.
Yeah, within the legend, and then a comma, and then you can put location with capital L. And since it's a string, you put in the two hyphens or whatever.
Mm.
Yeah. So it has to be within. You see how the words are written, susceptible, exposed, they are within those hyphens. So when you write as any string you write in your MATLAB, you have to put them in those, let me call them quotes.
Mm.
So location should be inside those
Inside
quotes.
those quotes.
Oh, okay.
And then comma best. Now, can you run and then see?
Oh, so it finds the position to put the.
It looks at the best position, the best possible where the legend is not interfering with the plot. If you want, you can just put maybe northwest. You can put there are so many positions. You can put northwest, northeast, northwest out, so that the region goes outside the plot.
But best checks the space which is free.
Yeah, best checks. Yeah, that so this is meaning these are like, let me call them housekeeping. You decide how you want your work to appear. So this is just appearance of your work. Is nothing, because somebody may cover that you have a legend which is blocking the curve. Somebody cannot see what's happening to to your work. So you can plot all these figures. So what will be changing when you plot these figures? There are only two things that will be changing. One is the correct file you read, right? And the parameter, of course, the parameters you read them. So in fact, you'll be changing you read the correct file, and you change the initial condition. You make sure that in each wave you use the correct initial condition for that wave. Yeah. But sometimes, because you want to discuss something, you may just keep the same initial condition, change the parameters. So you want to compare what is happening, what is the effect of these parameters when you keep everything constant. This one, somebody may want to investigate that one, right? You just want to see the effect of these parameters when you keep everything. But I said you remove the grid. You did not remove. Did you remove the grid?
Grid, yeah, we have a grid.
Before it was showing a title here.
No, I'm saying grid. You see the boxes, you know the grids.
In the code.
Within the figure, you don't see the boxes.
Yeah, they are there.
They are there.
I said maybe grid, but I think you put a grid, you remove the grid.
On. I think there is a grid. Yeah.
Grid,
Just about
you have the grid on, you have seen the grid. There's no more
yeah,
the grid.
Yeah.
No, I'm just removing them for uniformity with the other figures, because with the other figures I don't have the grid. But it's not an error when you have it. Yeah, so you see, there is no. But if you want, you can put the grid. But if for uniformity, you make sure that all your figures are, I think somehow they are uniform, right?
Okay.
Yeah.
Yeah, makes sense.
And then next, can you? So I said that. So when you want to run these figures, you'll only be changing. You read the correct file, and then you change the initial condition, right? Yeah. And then can you go? There's something I told you how to put the if condition. Did you put the if condition?
I was trying to put this condition here on the legend.
No, if condition. Because I told you that there's something you will want to do about the vaccine, because vaccination does not start. For example, when you go to wave 2, in wave 2, you don't have vaccination starting from the start of the wave, right?
No.
You have acceleration starting somewhere in the middle, because the wave 2 will start at time 250
250
and
actually.
vaccination starts at time 320. So you want to put something which you make sure that from 250 to 320, you have vaccination is 0, but from 320, you have vaccination. And in fact, that day we discussed and I told you to go and find out that one.
This we did in this.
No, I told you and you didn't. I just told you that you have to put because I told you that there's something we want to investigate. We will want to investigate what is the effect of introducing, maybe, how can I put it? What will be the effect on the disease depending on the time where you introduce vaccination? If you introduce vaccination at time 1, at time 10, at time 20, at time 50, what is the differences in the disease dynamics depending on the time point where you introduce vaccination? Just like the control measures we discussed, I was telling you about the control measures. The government does not introduce control measures immediately. They detect a disease, right?
Yeah.
So they introduce measures maybe after 1 week, after 2 weeks, after 1 month. So you may want to see the effect of introducing this at different time points. Yeah, and so that is one. That's why I was saying that if will be important. You can just go to the model equation, then you put if. First of all, how is your vaccination appearing? Can you go to the vaccination part? No, your parameters, where you just read the parameters. So because there are two things we want to play with. Theta, can you just add S to theta? No. So when I want to change the parameters in using a loop, I try to change the name and then I read the correct name after in the loop. Just add S theta and add S to epsilon. You can put theta t, so to miss it theta and then just t number t after. Whichever you want to put capital or small is whichever, provided you know the name, because we just make reference to that name, and then the same to epsilon. Right? And then I think epsilon will be, you can put yeah, for now, just keep it. But for the other one, it will be, you will be reading it from x1. You'll see that x1 has epsilon, right? Yeah, so you'll be reading it from x1. But just now go down to the model. And then so just after dy, whatever after those zeros, or before the zeros, whichever, just within that function. After line 120 even. After line 120.
Before, okay.
Okay, maybe okay.
Whichever. No, provide. No, don't. Why? What are you doing?
I'm just standing back. Okay, sorry.
There is no problem.
Yeah.
When you put it before dy, you will put after dy. Provided the first time it is used, it has already been declared.
Okay.
And then you can put if. How do you want to call it? I call it TVAC, right? But you can call it whichever name. Huh? So here, no, I think you have to now that thing has gotten work. You see that hyphen. That hyphen should be time, right? But so since it was not being used, so he put as hyphen, right? But so you can now return time in that hyphen. You can return the time, and then you can even call it t or t, whichever. So I just putting the hyphen in line 119. You see the hyphen in line 119. Is it hyphen or maybe is it called hyphen?
Minus sign.
No, the tilde. Not
Tilde.
the approximate.
Tilde.
Yes.
How is it called?
Tilde.
Oh, tilde. Yeah, so that tilde, because it's supposed to be this a model and it's reading the t, comma y. And so when t is not appearing, you can just put tilde to mean whatever variable is coming here, just take anything that comes in because you are not using it. But so since now we want to use it, you can now put something there. Just put T or TT. It means that's all the position for.
Yeah, that's right.
I prefer using small letters.
Okay.
That's always the place for the time. But so if in your model equations, you have, is it an autonomous system where you don't have time appearing anywhere, then you put tilde. But so now we want to be checking this TT and see that if TVAC is less than TT, then we put those parameters to be 0. The less than TT, and then enter. So you have theta is equal to 0. You have theta appearing right here as theta, right? In your model equations.
Yeah, theta, yes, theta.
Yeah, just put theta is equal to 0. Semicolon. And then else, enter, and then else. Theta is equal to theta t. The same thing can happen to, first of all, and then end. Once you do anything, you end. Once you start if, you end it. Yes, semicolon. That's something you have to get used to. No, not end. End, not semicolon theta. So first of all, just compute this, and we just want to make sure that there's no error, right? Yeah, that's now. Check. Can you check? And recognize. So you know what the error is, right?
I think it's a TVAC.
No, I'm asking him if he knows what the error, what that error means.
So I are not specified what TVAC.
Yes, that's the thing, because it says you are recognized, so you didn't specify, so you can go back and define your TVAC.
So
Continue. We said time starts at 320, so that is 320 because you said it starts at 320. Get used to putting semicolon whenever you write something. We finish. And then run. Changing one thing and then you run, just is you are trying to make sure that whenever there's an error, yeah, so you know what that error is, because we change this to be epsilon t, right? And so no, don't change it, because we wanted also to put that in the loop. No, not in the if, because the vaccination is affected. There are two parameters affecting vaccination, epsilon and theta. So go back and do the same thing you did to theta in the other end. When you don't copy you don't put two ifs and you're doing the same thing. Just put theta is equal to 0 and then epsi is equal to 0. Else, the same thing, epsi is equal to epsi theta. And since you know the same thing you're doing here, you will do the same thing on the other end. The difference just be that one will be a loop. Oh. Now run it and then see if you see now the model is working, right? You still have vaccination to be 0, right? So if you want to change this, if you want to test if this is working, can you go back to your time and change your time?
Start and end time.
Yeah, so I think that I'm now put to 50 for the second. I think 250 starts from the second wave. It's 250.
Yeah.
And then to just put anything more, even 400 or for 50 or 500.
500 or something like that.
500 for a sec.
Yeah.
Sure.
But the vaccination is still 0. Oh yeah. Why is still 0? Because you still have theta t and epsilon t defined as 0, right?
Yes.
Yeah. But so can you just change that one? Just put any number like theta t to put even 0.2. Or 0.3 even, whichever number. But so when you go to when you read the second lambda, the wave 2, you will find that they contain these thetas. And so you will put that appropriate theta. And then can you just put it to be maybe 0.8 or 0.9? I've just put this theoretical so that you see what is the effect. Can you come?
Yeah, there's the difference.
You see now the vaccination has, you see it starts from 0 and then it goes up. So that's the effect. So so this one allows you to compute this model, whenever time point putting into question that the vaccination might not start from the origin, it starts somewhere in the middle of the infection. Is that okay?
Yes.
Yeah. So now you can just put them back to 0. But when you read the wave 2 and the other waves, you put the appropriate values, right, from the load file you will read. Yeah. I think this is done about the general. So this is just about general solving the model and then seeing those simulations. And then I say that you'll do that one for the wave 1, wave 2, wave 3, and wave 4. And then you put new figures. You replace those figures of the Elias put, right? Yeah. Now, can you go back to, first of all, you can try to reproduce some of the figures Elias did. Can you go back to so these ones we have finished, those 4 figures. You can replace the appropriate figures and then you discuss them. Just go down first. This is fitting. Just after fitting, and just those are figures for fitting. So like no, there's somewhere effect of varying what? Phi, right? Effect of varying theta, effect of varying but now go down. Just go down. These are fitting figures. You see, like this one. This is varying what? This is varying phi, right?
Yes.
And so you can verify, and then you see what happens to phi. So I want to verify, but I said you will vary all those parameters, all those that Elias did. You will verify because that's control parameter. You want to see what happens. You can vary theta, is also control parameter vaccination. You can vary epsilon, right? What else? Do you have another control parameter? I think if you can also vary beta, but beta might be the same as phi, but we'll see. You can also vary beta. You can vary as many as possible, and then we'll see those ones which have interesting results. If you find them having something interesting to discuss, and then you put the figures. So you can vary most of these parameters, the ones which are appearing in the R note.
Okay.
Yeah. And once you know how to vary one, then it's much easier to. Can you now vary? Can you go to the other COVID, the other file? So can you just from the start from the beginning? We see the things which we have to change. So this is common until here, because all the others will be the same. You have to read the correct files and the correct parameters you want to use, right? So this will be common from until that line 19. It will be common from whatever you did in the general model. You just go down. So here, so this is now what we define. So this is the parameter you want to vary, right? Just call the general name epsi a, which will be whichever name parameter you want to vary. Like phi varies from 0 to 1, right?
Yeah.
That's the control parameter. And then number of divisions you want to make on phi, that one you can decide, right?
Mm.
Keep going. And then you will also read the correct initial condition you want to use. You can now, just for now, use IC1 B1.
This first one. Huh?
Yeah, but I'm saying that you will read the correct initial condition. So depending on the way we are investigating, you can just put the time, just put the initial time as we put the other end. Just even put 0 instead of 1, 0 to, just even put 0 to 300 or 400. When you see it's converged, then you can X limit your figure, right? Just put even 400, give it enough time so that you make sure that you have convergence.
Okay.
When you have numerical simulation, you don't restrict your time, just give it enough time. And then when you plot, you can plot the range you think is appropriate. And so H is equal to 0 epsilon A figure, J is equal to, those are a number of figures. And for J is equal to length epsi A, so phi is equal to epsi, right? So it means for each J you vary phi, that's correct. And then change the initial condition at in your line 60.
60.
You see, these are some of these are just common. Can you go down? H is plot. You can remove maybe this HJ. You can move HJ.
This one.
Because that's just labeling the figure. No problem. Just remove it. I think there is no problem in removing the HJ. But there's something I told you to do, but I know you didn't look at this, and I wanted you to look at this. So because I told you to go read, you know, the Matlab, the only way you can know these things is by looking at, you don't comment on that line, you just remove the HJ. That's the plotting. You cannot remove remove the HJ, not the whole line.
Oh.
That's the line for plotting, and then the equal sign. These things, when you will never know, because when you go to Matlab, then you have to Google these things, whatever you don't know, and then you Google and get the solution. Because of, but I've sent something in the chat, and then I tell you where to put the two things. Just copy them as up, copy them, and so the one text you can even put before line 68, the one I've sent. So you are now varying phi. You can now put that phi where there's theta. You put phi because you are varying phi. So you will put there the correct parameter you are varying. Phi is small letters. That's just latex. And then you are not varying m theta. You are varying what? Psi a, right? Where it's written numerical string, and I put m theta. Put your looping value. It's something psi a underscore a, and then your looping index is j, not I. Yes. And then so there's something I put display name text. So in the line after the plot, just after the line plot, the same line, plot y5, comma, dash, comma, and then you put whatever I put in the chat.
I copy that.
You copied the wrong things.
Okay.
Yeah.
Oh, is it correct one?
No, there is a display name.
There's a display name text. I sent
there's another one. Okay.
Yeah, sure.
So that one ensures it puts the correct legend automatically. So it will check the name and then it will put the correct value of the theta. Are you still, go back so that you combine the two lines because the two lines are split. Yeah, and then you can put, hold on, and then go down. Just go down until where the end of the figure, where you are. Oh, that's the end of the figure. This end is hold off. Oh yeah, yeah. The end is legend. Just instead of the legend, just say show legend instead of that line 105.
That's right.
Show legend. I'm a legend. Is it show legend or legend show whatever? Which one is correct? But some of these things you have to be doing them is legend and then show after hold off. Legend show. You start, so the reverse the two words. What is show legend is legend show.
Oh.
So
yeah, that is even also remove the 107 because now you are showing the legend. And then as we said, remove the title. Remove 107, remove the title.
Comment that one, I think.
Also remove 114.
Right.
And also copy. There's something in your model because now the two models have to be the same, right? Copy the same if thing in. But for now, don't copy it. You'll copy it later because I think we are getting running out of time.
Yeah.
Everything about the model and if will be the same. So you'll do the same things on the other end, what we did to the other end. Can you now run this file? So you see those numbers are coming by themselves, right? Yeah, but you have to check the model. I don't know if the model is okay and the parameters and whatever. You have to check those things and make sure that they are correct. Just verifying now, because since there was somewhere a mistake of K and kappa, just check to make sure that this mistake is not appearing in this part. In short, what I'm saying is in these two things, everything, they are the same except the looping part only. Yeah.
So I can just recopy the same what we had as the.
Yes, you can recopy and you see here, just wait, even the same model you see you are still having K.
Yes.
Yeah, so this mistake K, and the other is kappa, the other is K. So you can just copy everything the other end, which is like the model part and the parameter part, you copy them to this side. The difference part is only here you are looping and the plotting. And so you see the legend now, when you put the correct legend, you will only be changing. Can you go to the legend? When you put a certain parameter, for example, if it is theta, can you just go back to where you put the text txt? So you'll only be changing this parameter you read. Instead of phi, you put, if it is theta, you just put theta. If it's you put epsilon, that's the only thing you'll be changing. Then you have the automatic legend. So assuming you are varying theta, just instead of pi, you just put theta. And I made in such a way that you have the same, the only thing you change is line 68, the correct parameter, and then which line? Can you go back slightly? Where you are the loop is starting. Yeah, you have line 68, and then you have here, and then phi. So also line 53, you put the appropriate parameter you are varying, right? Yeah, so you put appropriate parameter. And then on the vector psi a.
That's line 55, yeah?
Yeah?
52.
Line 55.
If it's 55 only.
Oh, okay.
Yeah. 52 is not necessary because you remove the j in the other end. So 52 is not even necessary. You can remove 52.
Okay.
Can you go back to where you defined your psi a?
Yeah.
So you can now change, you can even change can you put even 8, even instead of 6, put even 10. I just want you to show the effect of this. Now run. You see, so you see, you will never worry about how many divisions I want, how do I put the legend, where, which are the positions of this legend. You don't worry because they are coming automatically. But mostly 10 are so many. Once you have sufficient number, 5, 6, 4, that you feel they are bringing out the picture of what you want to explain, then those are enough. Provided you have the appropriate interval, and then you so the rest of the things are common. Most of those things are common, and then you vary the parameters. And if you can get some results by evening, maybe it will be okay. I don't know if you are a football fan and maybe you're doing something.
Let me work on this. Grand down after this.
And okay, so you work on them.
Yeah.
Start with the general, produce figures, and then you save them, right? And then also the loops try to vary those parameters that Elias was varying. And then you vary those parameters, see the effect, and then you also save those figures. And you can send it to John and I, and also Elias.
Okay.
If you have time, we can discuss also in the evening or at night.
That's fine. That's okay.
Yeah, that'll be fine.
Yeah, after we have come from Emirates.
Hopefully things will be okay. Hopefully things will be okay.
No, we are whether we lose or what, we cannot stop working. But Nando doesn't watch football. John, do you watch football?
Yes, I'm a Chelsea fan.
But we can do it after Chelsea fan and Crystal Palace, right?
Yeah, because we can do it anytime. I mean,
yeah, even Nando can just, once you have the results, I don't know if you watch football, if you are watching, it's okay. But once you have the results,
yes,
you can send them to the email.
Yes.
Or you can put in the Dropbox and then share with that the Dropbox link. I think that will be.
I don't have the Dropbox now. I'm not contacted.
Huh? No, not necessarily the UK pass Dropbox. You can just put in your own Dropbox folder and then you share with us the link of that Dropbox folder.
Okay.
I think that's much easier than sending, because assuming you have so many figures, 20, 50, you will send all of them in the email. No, but whichever way, once you have the results, just share the results, and then we'll discuss if they are okay. Some of them, if they are okay,
we fix
and then
them.
We upload them. If there are some of them we have to, then we start now refining, we change. Because there's something I told you, and putting the looping, it will be the same thing. But that one we can discuss after you have these other figures of now where we vary the TVAC and introduce these interventions, like we vary the TVAC and introduce the interventions. We can also still just vary our own time and change time with respect to phi. Because phi is also the intervention parameter, right? Isolation and those response parameters. And if people do not respond immediately, there is an epidemic. So it takes time. So you want to see the effect of this, the time or how long people take to respond to the disease on the disease itself.
Yes.
And when we do this, later we will try to also to calculate some percentages. But so I want you to first get this just general figures, the general model, and vary these parameters, phi, theta, epsilon, beta. Just vary as many as possible, those which are appearing in the R naught mostly. Yeah. Even you can also vary K, you see what is the effect of these parameters. Some of them you may not have interesting results, some of them will be there. And then so we'll see which ones are interesting that we can discuss. Yeah. So that's a simulation. You do as many as possible, and then you see the ones which are interesting, those are the only ones you discuss. The others, you leave them.
Okay.
I think for now we can stop here, and then we go to Emirates.
So probably we can meet maybe at 8 or 8:30 today, Kenyan time.
Yeah, so I'm indoors. So weekend I'm indoors after football. I'm just here.
Let me do then. I'll share. Then we can get the 8 or 8:30.
8:30 is fine. So that's 8:30 your time.
Yes.
That's around 7:30. What time is Chelsea? Chelsea is starting at 5, right?
Yeah.
Yeah, so by 8:30 it will be it's okay. 7:30 is okay.
Okay, fine.
Yeah.
All
Okay.
right. That's
And
our
save the
time.
recordings. We'll refer to it later.
Yes,
Okay,
yes,
yeah.
yes. I
Okay,
can.
fine. Thanks.
Yeah, sure. And maybe you can also, Nandwa, you can share like these updated files.
Yes,
Matlab files.
I'll share. Yes, I'll share.
All right. Thank you so much.
Okay.
Okay, good.
Yeah. See you then.
Okay.